So, good morning, students. We'll continue with our unit number 3 and topic number 4, which is atmospheric pollution causes and effects, pollution mitigation measures. So, first one, what is atmospheric pollution? So, atmospheric pollution is the release of harmful chemical and material into the atmosphere. The results or consequences of atmospheric pollution can be devastating. That is, carbon dioxide, for example, is one of the major causes of climate change, while nitrogen oxide and sulfur dioxide combines to form harmful acid rain. Not all pollution is directly man-made, however, such as the release of ammonia from livestock. So ammonia is toxic to many aquatic animals and can lead to soil acidification and smog. So atmospheric pollution is also harmful to human health. Various causes of air pollution. First one, the burning of fossil fuels. Sulfur dioxide emitted from the combustion of fossil fuels like coal, petroleum, and other factory combustibles are one of the major causes of air pollution. Pollution emitting from vehicles including trucks, jeeps, cars, trains, airplanes causes an immense amount of pollution. We rely on them to fulfill our basic needs of transportation, but their overuse is killing our environment as dangerous gases are polluting the environment. So, carbon monoxide is caused by improper or incomplete combustion and generally emitted from vehicles, and it is another major pollutant along with nitrogen oxides that is produced from both natural and man made processes. Number two, agricultural activities. Ammonia is very common byproduct from agriculture related activities, and it is one of the most hazardous gases in the atmosphere. So use of insecticides, pesticides and fertilizers in agricultural activities have grown quite a lot. So they emit harmful chemicals into the air and can also cause water pollution. Number 3, exhaust from factories and industries. Manufacturing industries releases a large amount of carbon monoxide, hydrocarbons, organic compounds and chemicals into the air, thereby depleting the quality of air. So manufacturing industries can be found at every corner of the earth and there is no area that has not been affected by it. Petroleum refineries also releases hydrocarbons and various other chemicals that pollute the air and causes land pollution. Number 4, mining operations. Mining is a process wherein minerals below the earth are extracted using large equipments. So during this process, dust and chemicals are released in the air, causing massive air pollution. This is one of the reasons which is responsible for the deterioration of the health conditions of the mining workers, that is miners and the nearby residents of the mining areas as well. Number 5, indoor air pollution. Household cleaning products, painting supplies emit toxic chemicals in the air and causes air pollution. So suspended particulate matter, that is SPM, popular by its acronym SPM, is another cause of pollution. And referring to the particles afloat in the air, SPM is usually caused by dust and combustion. Next, disastrous effects of air pollution. First one, respiratory and heart problems. The effects of air pollution are alarming. They are known to create several respiratory and heart conditions along with cancer, among other threats to the body. So several million are known to have died due to direct or indirect effects of air pollution. Children in areas exposed to air pollutants are said to commonly suffer from pneumonia and asthma. Number 2, global warming. Another direct effect is the immediate alterations that the world is witnessing due to global warming. With increased temperatures worldwide, increase in sea levels, and melting of ice from colder regions and icebergs, displacement and loss of habitat have already signaled An impending disaster if actions if I've already signaled impending disaster if actions for preservation and normalization aren't undertaken soon. Number 3, acid rain. Harmful gases like nitrogen oxides and sulfur oxides are released into the atmosphere during the burning of fossil fuels. When it rains, the water droplets combine with this air pollutants, and it becomes acidic and then falls on the ground. In the form of acid rain. Acid rain can cause great damage to human, animals, and crops. Number 4, eutrophication. Eutrophication is a condition where a high amount of nitrogen present in some pollutant gets developed on sea surfaces and turns itself into algae and adversely affect fish, plants, and animal species. The green colored algae that are present on lakes and ponds is due to the presence of this chemical only. Number 5, effect on wildlife. Just like humans, animals can also face some devastating effects of air pollution. Toxic chemicals present in the air can force wildlife species to move to a new place and change their habitat. The toxic pollutants deposit over the surface of the water and can also affect the animals, sea animals. Number 6, depletion of the ozone layer. Ozone layer exists in the Earth's and stratosphere and is responsible for protecting the humans from harmful ultraviolet rays. Earth's ozone layer is depleting due to the presence of chlorofluorocarbons, hydrochlorofluorocarbons in the atmosphere. As the ozone layer will go thin, it will emit harmful rays back on the earth and can cause skin and eye related problems. Ultraviolet rays also have the capability to affect crops. Next, pollution mitigation measures. So the first one is reduce use of automobiles. Second is identify the sources and works to limit them. Third is support and encourage afforestation. Fourth is energy conservation and encourage the use of alternative renewable sources. Fifth is raising awareness, and sixth is strengthening the environmental institutions by helping countries improve environmental governance, regulation, and enforcement. So that's all for this lecture. You can give your attendance in the chat box, and I have been telling many times in my previous classes that during the lecture those who gives the attendance, and until and unless I ask for it, those who give the attendance during that period, I will not consider it. From the last classes I have been considering it, but from next class onwards, if someone gives attendance, in fact before even I ask for it, I will just throw that student out of the meeting as it is supposed to be, because you people are not listening to me.
Hi, and welcome to this overview of air pollution. Air pollution is a major public health issue. In this video, we'll discuss outdoor air pollution, what it is, types of pollutants, and sources. We'll also take a look at ways to reduce air pollution and talk about how air quality is monitored. We'll then talk about indoor air pollution, why it's a problem, sources of pollution, and ways to reduce it. But first, what is air pollution? Air pollution occurs when the air is contaminated with any chemical, physical, or biological agent. It is the world's largest environmental health risk, leading to millions of deaths around the world each year. Although anyone can be affected by air pollution, people who are most vulnerable include the elderly, children, and people with chronic lung or heart disease. Let's take a look at outdoor air pollution first. The outdoor air can be polluted by natural sources or human sources. Natural or biogenic sources of air pollution include pollen, bushfires, or dust from deserts. Pollution of the air from human sources, also called anthropogenic air pollution, is commonly due to industries, burning of fossil fuels, and the use of motor vehicles. There are hundreds of different types of air pollutants. Let's take a quick look at a few important ones. Particulate matter is a complex mixture of small particles and liquid droplets that are mainly from industry or motor vehicle exhausts. Dust storms or bushfires can also generate large amounts of PM. Particulate matter is classified according to the diameter of the particles. The health effects of particulate matter are mostly due to particles that are less than 10 micrometers in diameter. These particles can reach the deepest parts of the lungs and enter the bloodstream. Nitrogen dioxide is usually formed when fuel is burned at a high temperature. Common sources are the exhaust of motor vehicles, industry, power plants, and gas stovetops. Carbon monoxide is colorless and odorless and is formed when the carbon in fuel doesn't burn completely. The main source of carbon monoxide is motor vehicle exhausts, and therefore, carbon monoxide levels are very high in areas with heavy traffic congestion. Other sources include industry, incinerators, and bushfires. Sulfur dioxide is a gas that can be produced when sulfur-containing fuels are burnt during industrial processes like in power plants and refineries. Lead is produced mostly as a result of metal and ore processing. Motor vehicle exhaust used to be a major source of lead pollution. However, regulatory efforts to reduce lead in fuel has led to a massive reduction in lead emissions. Ozone is a gas that is not emitted directly to the air, but is formed as a result of sunlight acting on other chemicals in the air. Ground-level ozone is a pollutant, whereas ozone that occurs naturally in the upper atmosphere has a protective function. There are hundreds of other air pollutants that can lead to adverse health effects. Okay, so what are the health effects? Exposure to air pollution can result in a wide range of short and long-term health effects. The health effect will depend on factors like the type of pollutant, concentration, length of exposure, and individual characteristics of the person exposed to it. It can range from minor symptoms like irritation of the eyes, nose, and throat to more severe conditions like heart and lung disease or cancer. It can also lead to increased hospital admissions and an increase in death rates. In 2012, outdoor air pollution was estimated to have caused 3.7 million deaths around the world. In addition to causing health effects, air pollution can also lead to damage to property, reduced visibility, and have other effects on the environment, like acid rain. What can we do to reduce air pollution? Well, there are many different ways to reduce air pollution. These require the combined efforts of governments, industry, and individuals. For example, governments can take actions like developing standards, regulating the level of pollutants in the air, developing policies to reduce environmental impact of development, and using clean energy sources. Industry can take steps like reducing their emissions to the environment, taking measures to prevent pollution accidents, or developing technology to reduce emissions, like electric cars. At an individual level, reducing the reliance on fossil fuels can be achieved with actions like walking, using public transport, or choosing energy-efficient means of living and transportation. Let's have a look now at how air quality is monitored. Most countries have national laws and regulations to control air pollution. These usually set out air quality standards that must be adhered to. These standards are set out by each country and will depend on factors like technological feasibility, economic considerations, capacity for air quality management, political and social factors. These standards specify the concentration of a number of selected pollutants called criteria pollutants that are allowed in the air. A useful way to track air pollution against the national standards is a measure called the Air Quality Index, AQI. This is a simple numerical or color-coded representation of how clean the air is. There are different ways of calculating the AQI, but it's essentially a measure of what the level of a pollutant is compared to what the national standard is. Now that we've had a look at outdoor air pollution, let's have a look at indoor air pollution. Now, although the indoor air quality is affected by outdoor air, the quality of indoor air can be significantly different. This is because there could be many sources of indoor pollutants. The most common source of indoor pollution in the world is solid fuels, like wood, charcoal, dung, or crop waste that are used for cooking or heating. Around the world, over 3 billion people use simple stoves or open fires to cook or heat their homes. These methods are inefficient and can lead to the generation of pollutants like particulate matter, which can result in concentrations indoors of up to 100 times more than that of the outdoor air. Other sources include tobacco smoke, chemicals released from building materials, furnishings, and household products, pesticides, asbestos-containing insulation, and products used for household cleaning. Factors like inadequate ventilation and, in some cases, heat and humidity can worsen indoor air pollution. Exposure to indoor air pollution can lead to health effects similar to those caused by outdoor air pollution. In 2012, the World Health Organization estimated that 4.3 million people died due to illness that could be attributed to household air pollution caused by the use of solid fuel. There are several ways to reduce indoor air pollution, including controlling it at the source. This includes actions like changing from solid fuels to cleaner and more energy-efficient solutions like biogas, electricity, or solar power, improving cooking devices, and reducing the need for open fire heating by constructing energy-efficient housing. Making improvements to the indoor environment. This may include increasing ventilation through windows or chimneys, or other design features like having the kitchen separate from the house. Behavioral changes like properly maintaining stoves and chimneys can reduce the accumulation of pollutants. Exposure to indoor pollution can also be reduced with actions such as using pot lids to conserve heat and minimize cooking time. So that's a look at air pollution, an important public health issue. We've had a look at outdoor air pollution, different types of pollutants and their sources, ways to reduce pollution, and how air quality is monitored. We've also talked
When we think of air pollution today, we think of cities like Beijing. I spent a week there and I could never see the sun. In this picture, you can see before and after a rain, which has knocked a lot of those chemicals out of the atmosphere. And these chemicals have adverse health effects. And so we saw that in Western Europe. In London in 1952, they had the Great Smog. It was difficult to see, but thousands of people died, and that led to legislation. We had the same problems in North America. And so what is air pollution? It's not only chemicals in the atmosphere, but chemicals that have bad health effects. And since we're breathing it in, it's going to affect our lungs, our heart, and can lead to increased cancer risks. Where are these chemicals coming from? Well, they can be produced naturally. And so we have forest fires and volcanoes that can produce these pollutants. But also we have stationary sources. You can think of those as industrial, like factories. And then we have mobile sources. That would be like cars and buses. And so if they're affecting us negatively, we call these pollutants. And in AP Environmental Science, you simply should memorize the different types of pollutants that I've listed here, starting with volatile organic compounds, or VOCs. This would be like formaldehyde, gasoline, anything that's organic and can diffuse into the environment. We've got carbon monoxide, this odorless gas. We've got NOx, which is going to be both nitrogen or nitric oxide and nitrogen dioxide. We then have sulfur dioxide produced through the combustion of coal. We then have particulate matter. These are going to be suspended solids. And then finally, we have chemicals like lead. These are all primary pollutants. That means they're produced by the source themselves, but they can combine with other chemicals in the atmosphere and produce secondary pollutants. So for example, NOx can produce nitric acid, and sulfur dioxide can produce sulfuric acid. And these combined can produce acid rain, or more generally acid deposition, that has huge impacts on life. And then one of the pollutants that you're probably most familiar with is ozone, that can be produced through sun. And also we need nitrogen dioxide to produce that. And if we can combine a lot of these, then we have smog. It's probably the most famous type of air pollution that you're familiar with. And it's exacerbated by things like temperature inversions. So how do we control air pollution? Well, with regulation is one way. The Clean Air Act in the United States was able to reduce pollutants and save lives. And so technology is able to scrub those pollutants out of the air before it's released. Where is the air pollution coming from? What are the sources? They can be stationary, like this factory. They could be mobile, like all these cars stuck in traffic, or it can be natural. Remember, like giant forest fires can increase the amount of air pollution. But regardless, how do they affect us? It's through our cardiovascular system. It's just like smoking. You can think of it that way. It can lead to lung disease, heart disease, and increased risks of cancer. And so where do we see these health effects most? It's wherever we have industrialization. So clearly it's going to be in places like China, but look over here on Eastern Europe, we have huge amount of industrialization and not a lot of regulation. And so let's go through those primary pollutants again. We've got VOX, which are volatile organic compounds. An example could be this gasoline that's evaporating into the environment, formaldehyde. If you smell a pine tree, those are VOX, or organic compounds that are coming off and can lead to things like smog. We've got carbon monoxide, which is produced naturally through photochemical sources, but also can be produced through combustion. All of these sources produce carbon monoxide. We then have NOx, which is going to be nitrogen or nitric oxide, and then nitrogen dioxide. It's this brown gas that contributes to that color that you see in smog. We then have sulfur dioxide. You've probably smelled that if you've ever been around a coal plant. And you can see here that in the US, it's going to be restricted to the East Coast generally because we're going to have more industrialization there. And then we have particulate matter. These are going to be small solids. This is from the EPA. So you can think of sand as an example of a particulate, but it's not small enough. And so this is your hair. It's going to be on the order of 50 to 70 microns. And so we're talking about things that are smaller than that. Small sediments that as you breathe it in, the hairs in your nose and respiratory tract don't trap it. It goes into your lungs. And just like smoking, it's stuck there and can lead to other types of diseases. And then we have chemicals like lead. We used to add lead to our gasoline. And there's huge neurological impacts of lead. Now, again, these primary pollutants can produce secondary pollutants. And so the nitrogen and the sulfur can lead to nitric acid and sulfuric acid. And these lead to acid rain. It can dissolve statues like this, but more importantly, it changes the pH in the whole food web and can impact living systems. And then we have ozone. Ozone, we've talked about before, can be good. And so if we look at the stratosphere, way up here in the stratosphere, remember the ozone, which is produced naturally, is blocking harmful UV rays. But if we move down near the Earth, it produces a tropospheric ozone. We call that bad ozone. And it's one of the large things that contributes to smog, photochemical smog. And so photochemical smog, this is some in Mexico City. You can almost draw a line here and say the smog is below that line. Well, what you're looking at there is a temperature inversion. And so the heat is inverted. Let me show you what that looks like. And so if we have in this environment, the sun is heating the earth. And so we're going to have the air near the earth warmer. And so if we look at that gradient, it's going to go from warm at low altitude to cool and then cooler air as we move up. And this gradient is going to move a lot of those pollutants up and then away from that city or wherever they're produced. But sometimes due to currents or wind or just the geography of the city, you can get what's called an inversion. And so instead what we have is a layer of cooler air near the earth. And so it's inverted. And so as we move up, it gets warmer and then it gets cooler after that. And so what you're doing is you're trapping all those pollutants near the surface of the earth. They can't move up and they can't move away. And then we start to have chemical reactions going on. And so photochemical smog is caused by these three things: NOx, VOX, and the sun. And so if we look at that chemically, this is nitrogen dioxide. And if you have sunlight, what happens is that will break a free oxygen atom away. Now that free oxygen atom can then combine with atmospheric oxygen and it can produce this ozone. And so what is smog? It's essentially these NOx compounds, and then it's going to be this ozone. But naturally what will happen is that these will spontaneously move back to nitrogen dioxide and regular tropospheric oxygen. And so again, to make smog, we have to not only have NOx and the sun, but we have to have these volatile organic compounds as well. And so how does it work? We break apart that nitrogen dioxide again. So we're producing this nitric oxide, and that will combine with these volatile organic compounds in the atmosphere itself. And so now what happens is that we produce this ozone, but it's not spontaneously going to go back again. And so how do you form smog? We have to have these volatile organic compounds, we have to have this nitrogen dioxide, and then we have to have sunlight. And so areas like Los Angeles, where all of these come together, have a huge amount of smog. How do we prevent it? We prevent the amount of nitrogen dioxide, and we prevent the amount of volatile organic compounds in the atmosphere. Now, how do we eliminate air pollution? We do that through legislation. So we have restrictions on the amount of pollutants. And so the Clean Air Act is probably the most famous one in 1970. And what they did is they put strict standards on these pollutants over here. And so in industry, you're limited on how many of these pollutants you can put into the atmosphere. But how do we do that? Technologically, we can use a catalytic converter. This is essentially grabbing onto that nitrogen dioxide and carbon monoxide that's produced in combustion. We can then use mechanical filters or electrostatic filters like this. They'll produce a gradient and it grabs onto some of these pollutants. We can scrub the air, and we can use wet scrubbers as well. So as the air goes in, the polluted air goes in, we have a mist eliminator. So there's water here, and that water will grab onto a lot of those chemicals. They'll move down into this packing material, and then the clean air is going to go out the other side. And so did you learn the following? Could you pause the video at this point and go through and fill it all out? Well, let me do that for you. It can cause lung disease, heart disease, and then increased cancer risks. Those chemicals could come naturally, they could come stationary or mobile sources. We can control that through the Clean Air Act and technology and regulation. If we look at the pollutants themselves, again, in review, it's VOx, carbon monoxide, NOx. That produces nitric acid. We have sulfur dioxide, particulate matter, and then things like lead. These acids can lead to acid deposition, and the combination of all these produces smog, which is exacerbated by temperatures inversions. And so that's air pollution. It's deadly if we don't regulate it, and I hope that was helpful.